Hello, ladies and gentlemen. Today we're going to be talking about compositions of transformations. So you're going to need something to write with and your notes. And our essential question or our guiding question for today is what is a composition? First of all, like what is it? And then how do I perform it correctly? So the definition of a composition of transformations is when two or more transformations are combined to make one final image. So far in this unit, we've learned how to translate, rotate, reflect, dilate, all these things. Now we're going to combine them together and do multiple transformations for one full composition. So again, thinking about our notation, when we talk about prime, double prime, pre-image, image, all that stuff, if we look at the examples, these three pictures, they're all three different examples. If we look at the far left one with the like orange, blue, and red triangles, we have to think to ourselves, like, what is the direction or what is the composition order? So we're starting with the blue image, and the reason why I know that is because my points A, B, and C are labeled with no apostrophes. From there, we must be going from the blue image to the red image because now we have an A prime, B prime, C prime labeled with our ordered pairs. And then from there again, we must be going to the orange image from the red image. So the composition is taking us through all of those transformations. It looks like we started in quadrant 1, we had a reflection over the x-axis, and then we had a translation to the left so many units. Again, over here, we're going to go from this image to this image now that we don't have any colors. We're going to go from quadrant 2 to quadrant 3 with the reflection over. It almost looks like the y-axis, but I think it's technically over this line, y is equal to 1/2. And then it looks like we're rotating our image from this point over into like quadrants 1 and 4. So that is today's goal is not only to perform compositions of transformations, but also to easily identify what was the order that was happening. And the only way we're going to know that is if we label our ordered pairs accordingly with the appropriate prime symbols and double prime symbols and so on and so forth. So our first example is to actually perform a composition. And this sounds like it's going to be like a lot of work, but really it's just doing multiple transformations on one graph. And that's all we're doing. So triangle JKL has vertices of J1, -2, K4, -2, and L3, 0. We want to first reflect the triangle across the x-axis and then second rotate it 180 degrees about the origin. For all of our problems today, I would love for us to not only draw the things on the picture, but also write down our ordered pairs and our coordinate notation to see what's happening. So I have plotted my points J, L, JK, and L. I wrote down their ordered pairs. Our first transformation is we want to reflect it across the x-axis. If we think back to our coordinate notation, that is xy mapping onto x negative y. So I can simply just count, and that's how I came up with my second image. I can count from the x-axis. I went 1, 2, so I'm going up 1, 2. That's how I plotted J prime. Same thing with K. I went up 2 rather than down 2 from that x-axis, and then actually L prime didn't move at all. But if we didn't have a graph in front of us and we had to solely rely on the ordered pairs, we would need to go back to this coordinate notation that xy maps to x negative y, which means that all of my y values of my ordered pairs should change symbols or change signs. So I went from 1 to for J, I went from 1, -2 to 1, 2, and so on and so forth. So now we're starting with those same ordered pairs, J prime, K prime, and L prime. So from that blue triangle now, for our second composition, we're going to rotate the blue triangle 180 degrees about the origin. Sometimes it's easier for us to start with the coordinate notation or that rule and then plot our ordered pairs and then, find our ordered pairs before we plot them. So the rule for rotating 180 degrees about the origin is xy maps to -x, -y, which means that J prime to J double prime becomes -1, -2, K prime to K double prime becomes -4, -2, and then L prime to L double prime means that we have -3, 0. And that's how we would plot our ordered pairs. I would plot J double prime at -1, -2, -4, -2 for K double prime, and then -3, 0. So our final resulting image would be the green image right there in quadrant 3. Some more things to know about compositions of transformations. Sometimes questions may ask you to simply do one ordered pair with multiple transformations rather than graphing all the things. So the symbol for a composition of transformations is an open circle, and the notation looks like this. It can look like any kind of reflection, translation, dilation, rotation with that open circle, and then another one. How we read it as reflection in the x-axis following a translation of x plus 3, y plus 4, or xy maps to x plus 3, y plus 4. So that's super confusing language, because technically, if you look in the box below, you're doing the thing that is listed second first. So the first thing we're doing is we're translating the image to the right 3 up 4, and then we're going to reflect it across the x-axis. Because of the word following in this notation for that open circle, it actually reverses the order. So we're going to look at some examples on what I mean. So we have the pre-image point, and then they gave us that notation of what compositions we have to do with them. And then we have to find the final image, or the double prime ordered pair. So if we start with the point -2, 8, we are going to do a compositions of dilation 1/2 following the reflection of over the y-axis. So we're starting with that ordered pair of -2, 8, and we're going to reflect it in the y-axis first. So with our rule or our coordinate notation, we're technically changing the value of that x ordered pair. So we're going from xy to x -xy. So our new ordered pair is 2, 8. From there, we are dilating that point 2, 8 by 1/2. With a dilation, we just multiply all the ordered pair numbers, all the numbers in the ordered pair, by that scale factor, which is 1/2. So 2 times 1/2 is 1, 8 times 1/2 is 4. So our final answer for our image would be 1, 4 for our ordered pair. Let's look at example number 2. So we have a pre-image point of -3, 4, and the compositions of transformations is a dilation of 3 following the translation of 3, 2, the vector form 3, 2. So if we change that vector form into coordinate form, we're going from xy maps to x plus 3, y plus 2. So we're taking that pre-image point, -3, moving it right 3 to a ordered pair of, or a coordinate point of 0. And then we're going up 2, so we're changing that coordinate point of 4 up to 6. And then from that 0, 6 point, we're going to dilate it by a scale factor of 3. So x, for your x value, 0 times 3 is still 0. For your y value, 6 times 3 is 18. For a final answer for our image point of 0, 18. And we have one more. We have a pre-image point of 3, 6, and the compositions of transformations is a translation in the vector form -4, -5, following a rotation of 180 degrees. So again, using our coordinate rules and our coordinate notation, we know for rotations of 180 degrees, we map from xy to -x, -y. So we're changing that ordered pair 3, 6 to -3, -6. And then from there, we're translating it left 4, down 5. So that changes our ordered pairs to be from starting at -3, -6. We're going to take -3 minus 4 to get -7. We're going to take -6 minus 5 to get -11.